All right, welcome to our video notes for day 4.4. Originally, this was going to be posted for you to watch at home, but due to some other circumstances, we're watching it in class. Thank you for cooperating and following along. We're talking today about some proofs using similarity. And as we talk about proofs, there's some things I can show you as far as shortcuts go, but really we're just trying to show what we know to be true about these figures, especially triangles, using the reasons for triangles to be similar that we've already talked about. So when we are trying to prove that triangles are similar, we're going to use things like side-side similarity, side-angle side similarity, but mainly we are going to be using angle-angle similarity because that is the easiest method because I only have to show two things. And I don't have to worry about using equations like proportions to show anything about sides. So to do a proof, we're really going to try and make sure we can always just use angle-angle similarity. But we are also going to look at how we can prove or show that other polygons are similar. Now to show that other polygons are similar, we're showing two things, and only two things. The first thing we're going to show is that corresponding angles are congruent. Okay, you have to show that all corresponding angles are congruent. But then we also want to show that corresponding sides, I'll abbreviate that, corresponding sides are proportional. And we are going to do this in a little bit more informal method. We're not going to write this out as a two-column proof for proving polygons are similar. We're going to kind of write it out as a verbal explanation. So we'll get to an example like that later on. But first, we are going to take a look at a proof proving that these triangles are similar, and these triangles don't work out in a nice, neat function or pattern because they don't match up the way you think they will. But remember, we want to try and use angle-angle similarity whenever we can. Well, looking at what is given to me, all they give you is this triangle picture, but they do give you that they have a pair of angles congruent, that AED, this angle, is congruent to ACB, this angle. And that's just given to you. There's no other way for me to know those are congruent. Well, that's one of the pairs of corresponding congruent angles. I need another pair, but you'll notice that both triangles, this little one, AED, and this big one, ACB, they share angle A, meaning angle A is congruent to itself by the reflexive property. So that's the other pair of congruent angles. So this proof is actually fairly simple. We start off with our given statement. Angle AED is congruent to angle ACB because it's given. Then we can use the vertical angles that angle A, I'm sorry, not vertical angles, reflexive property. Angle A is congruent to itself. See, I even said the wrong thing, but that's the reflexive property of congruence. Hopefully you're paying attention and listening and catching me on these. Which, that's the other pair of congruent angles, which makes these similar triangles by AA. So that's our final step. Triangle AED is similar to triangle ACB by angle-angle similarity. And that's what we're trying to prove. Okay, so we're going to take a look at our next example. We're going to use our given information and prove that these triangles are similar. Notice the given information is that we have parallel lines. ED is parallel to CB. And so I'm going to go ahead and mark those here. I need you to remember that anytime we have parallel lines, that creates congruent angles. Okay. Parallel lines give us either alternate interior angles, congruent, or corresponding angles are congruent. Now, either way, we also have alternate exterior angles. You're not really going to use that one as much. It's going to be one of these two. Okay, so we're going to start with our given. Statement 1 is just the given statement that ED is parallel to CB. And then I'm going to look for the pairs of angles that can be congruent directly from that. Okay, well, I can go on either side of this and look at angle E and angle C. Those are corresponding angles. Same thing over here for D and B. Well, there's already two pairs of congruent angles, but we also have the reflexive property we could use. I don't need to use all three. So here's what I'm going to do. I'm going to say that angle E, or rather angle AED, is congruent to angle ACB because those are corresponding angles. Okay, you need to be able to recognize that these are corresponding angles because they're both to the left of this transversal AC and they're both above their respective lines from the parallel lines. It's like I could slide angle E down right on top of C and it would be the same angle. So those are because they are corresponding angles that are congruent. Okay, and that's one pair of angles, but then for the same reason I could also say angle D is congruent to angle B, or angle ADE is congruent to angle ABC for the same reason. That covers angle-angle similarity. So I can say triangle AED is similar to triangle ACB by angle-angle similarity. And that finishes the proof. Okay, to do this proof in this next example, there's actually some misinformation given. I've given you the wrong information. There's a way to do this proof with this kind of information, but it gets really tricky to try and incorporate proportions into this kind of a proof. So I'm actually going to make this easier on us. We're going to skip this. Okay, we're going to leave this as my given information, but then instead of this information, okay, instead of all that with the numbers, we're going to say that triangle FXC, okay, we're going to call this point X, because otherwise it's not on there. Triangle FXC is isosceles. Okay, that's the abbreviation for isosceles. What that means is FX is congruent to XC. All right, those are going to be my sets of given information. We're going to still prove that these overlapping triangles ABC and DEF are similar. Okay, so we're going to start off with that first given statement. Segment AB is perpendicular to BE, and segment DE is perpendicular to BE. Okay, that creates right angles there. And we're also going to say that our other given is all inclusive here. FXC is isosceles. That's all given information. And again, we want to be able to use angle-angle similarity here. All right? So I need to look at some angles that could be congruent. Well, from the first pair of givens that these are perpendicular, that creates congruent right angles. All right, since these are both right angles, all right angles are congruent. So I can just say angle B is congruent to angle E because right angles are congruent. That's a reason you can use in a proof. Anytime you're saying that right angles are congruent to each other, you just write right angles congruent. But we also know that angle F and angle C have to be congruent to each other because they're the angles in an isosceles triangle, or our isosceles triangle theorem. So I can say angle XFC is congruent to angle XCF. Okay, by our isosceles triangle theorem. If you remember back to Unit 3. Well, that creates angle-angle similarity. So step 4 is triangle ABC is similar to triangle DEF by angle-angle similarity. All right, for our final proof in this lesson, we are using rectangles this time. These are both rectangles, and they give me some dimensions here. We're going to need to use this to show that ABCD, which is a rectangle, is similar to EFGH. Since these are not triangles, I cannot use angle-angle similarity or side-side-side or any of those. Those are only for triangles, so I can't use that. So I'm going to actually go back here to what we said at the beginning and just show that corresponding angles are congruent, corresponding sides are proportional. So we are going to write this out as what we call a paragraph proof. Okay, and we're basically going to write out our proof in words. Okay, so we're going to just start off with stating what is given. All right, we're going to state our proof like this. It is given that A, B, C, D, and E, F, G, H are rectangles. Okay, and we're just going to write that. AB equals 14, BC equals 6, EF equals 7, and FG equals 3. Okay, we're just going to write that. And I am going to draw this out for us, all right, because I need you to understand some things here. I've got A, B, C, D. The vertices of this rectangle have to be in that order. We go from A to B to C to D. And then we also have E, F, G, H. E, F, G, H. And in writing this out, you understand which sides go together. I know that AB has to go with EF. And the same is so on and so forth for the rest of these. But because these are rectangles, all the angles of a rectangle are right angles. So that's what I say next. I can say, since all angles are right angles, corresponding angles are congruent. So that sentence right there takes care of half of what I have to say. Okay, I have to show that corresponding angles are congruent. Since they're all right angles, they all have to be congruent. Okay, so that takes care of that part. Now I just have to show that corresponding sides are proportional. And so all I'm going to do is write out this statement. Since AB over its corresponding side would be EF, since that equals 14 over 7, which when I simplify it equals just 2, and I'm going to do the other corresponding sides, BC over its corresponding side FG equals 6 over 3, which also reduces to 2, and opposite sides are congruent in rectangles because they're parallelograms. Since all that is true, corresponding sides are proportional. Since I've shown these two sentences, and I'll underline them for you, since I've shown those two things, corresponding angles are congruent, corresponding sides are congruent, I can finish my proof by saying this. Therefore, ABCD is similar to EFGH by definition, meaning the definition of similar polygons. All right, so that finishes my proof using a paragraph proof. All right? Well, hopefully this helps. You have a little bit more time now to work on the assignment in class. Please come in and see me if you have any extra questions.